Hello again. As we mentioned in the previous video, there is an angle between the orbital axis, this axis, and the spinning axis, the red one. This angle is called obliquity of Earth or tilt of Earth. At the moment, it is 23.4 degrees, but it has not been the same. Every 4,000 years, there is a minimum and maximum change, as well I will explain later. First of all, let's answer this question that why Earth has a spin at all. The answer is at the beginning of formation of our solar system, all the planets were in hot gaseous spinning state, and this spinning kinetic energy is remained up to now. Let's have a look at this picture. This is the Earth. This is the central axis perpendicular to the orbital plane. As I said, we have one minimum and one maximum. We have two extremes for the spinning axis. This is the spinning axis. The spinning axis. At present time, the spinning axis is oriented toward the North Star or Polaris. In about 13,000 years later, or in future, we are going to reach this point, this position, which is oriented toward the Vega star. So the complete circle is covered in 26,000 years. This circle is called precession of Earth. Precession of Earth. And it is due to gyroscopic effect of the Earth. Here, please notice that at all times the axis of spin, here or here or here or here, which are on this circle, that at all points they have the same angle, 23.4 degrees with this axis, but they are moving on this axis. Okay. Now, let's give some more explanation here. This is a spinning top, is a plating. Maybe you have a plate when you were a child. It is a spinning. While spinning, the axis of this object, the top, also rotates around a circle like this. This circle is called precession. Okay. Earth is also like a giant spinning top and acts like a gyroscope and has a circle of precession like this. There are two ways of stating the change of angle of tilt. At the moment, the Earth currently has an axial tilt of 23.4 degrees. Because the Earth's orbit changes gradually over time, this angle changes over time too. In fact, it changes by about 0.88 degrees every century. every century. Using the numerical methods to simulate solar system behavior over a period of several million years, long-term changes in Earth's orbit and hence the obliquity have been investigated. For the past 5 million years, Earth's obliquity has varied between 22 degrees 2 minutes and 33 seconds and 24 degrees 30 minutes 16 seconds with a mean period of 41,040 years. In this three figure, you can see the 24.5 maximum, 23.5 present state, and minimum tilt 23.1, and from here to here it takes about 41,000 years to go from this state to this state or this state to this state. Please note that on Earth climate, how does the precession? Please note that both tilt angle and precision position of axis have impacts on Earth's climate. So both tilt and position of the axis on precision circle has some impact on climate. How does the precession of of the axis affect the planet's climate? Precession is the cyclic change in Earth's rotational axis, amounting to roughly 1 degree every 72 years. This is another way of stating the variation of precession. One major effect of precession is that at different times during the cycle, the seasons will be either more or less extreme in the northern or southern hemisphere. This was for precession change and its effect on climate. What about the tilt? How does tilt affect climate change? What causes the Earth's climate to change? The tilt in the axis of the Earth is called its obliquity. This angle changes with time, and over about 41,000 years, it moves from 21 degrees to 24.5 degrees and back again. When the angle increases, the summers become warmer and the winters become colder. Please note that axis change can be both natural, I mean external, or by changes in land conditions on Earth itself. Human can cause that. North Pole ice sheet melt and water penetration into the interior layers are examples of this, as I explained. In linear motion, kinetic energy is given by this formula, 1/2 multiplied by m multiplied by v to the power 2. In angular motion, kinetic energy formula is given by this. Energy is equal to 1/2 multiplied by I multiplied by omega to the power 2. M is the mass of the moving object, V is the velocity, I is the moment of inertia of the spinning object around the axis. Omega is the angular speed. Each rotating object around an axis has a moment of inertia. Depending on the shape or the object, for example, for a sphere spinning around its central axis, like Earth, the formula of moment of inertia is given by this formula. 2 divided by 5 multiplied by m multiplied by r squared. Now see the use of these formulas here. If the melt if the snow or the ice in the North Pole melts, it is going to flow down on the equilateral plane like this. And here they are going to spin with the Earth, but with a larger radius. When the ice were in the pole, the radius of the spinning was small and did not contribute too much to the moment of inertia which is given by this formula. When it is on equilateral plate, radius is large and the moment of inertia is going to increase. Moment of inertia is increased, and then come here to this formula of energy. Energy of Earth is conserved, cannot change suddenly. It's constant. And the moment of inertia here, moment inertia, has increased. So, to balance this formula, omega should decrease. Means the Earth should spin slower. And this is what has happened. And there are various reports that the Earth is spinning slower, maybe a few milliseconds in a day. Okay? Then come here. If we have some water here, some mass of water here, and it is penetrating, going inside the interior layers of the Earth like this, like this. What happens? The thing that happens is that this mass of water is spinning with a smaller radius, with a smaller radius. And the according to the formula for moment of inertia, since the radius is reduced, moment inertia is reduced, moment inertia is reduced, and we come here to the energy. Here, energy is constant. This one, moment of inertia has decreased. So to balance the equation, the omega should increase. It means that the Earth should speed up very easy. And also we have some reports that says that the Earth has speed up during the past years. Here is some information about the Vega star, and here is some information about the Polaris North Star. Next video, we are going to talk about gyroscope principles and formulas and Earth as gyroscope.